Hello, my name is Andy Pickard. I am the chair of the ICSI Corporate Advisory Board, and it is my pleasure to welcome you to the 19th ICSI webinar. This month's webinar is by Garry Roedler, who is Engineering Outreach Program Manager at Lockheed Martin Corporation. Garry will give a presentation on leading indicators for systems engineering effectiveness. Before Garry begins, I just want to take a few seconds to explain the webinar program. The ICSI webinar series came about because of a request from the Corporate Advisory Board at the 2008 International Workshop to provide a way for members to get current information on a regular basis. We will provide both current technical topics as well as help people understand how to get the most out of ICSI. At the end of this webinar, I'll go over the upcoming schedule. Garry will talk for about 35 to 40 minutes, during which time you will be able to see his PowerPoint slides and hear him speak. This is a one-way presentation. You will be able to hear Garry, but none of you will be able to ask questions or provide comments. With dozens of participants, there's no effective way to have people ask questions orally. Instead, we will take advantage of the live meeting Q&A feature. All of you should have a pull-down menu at the top of your browser called Q&A. If you think of a question for Garry during the talk, please write it in the Q&A box. We will accumulate all your questions during the presentation. When the talk is finished, Garry will look at the questions you have submitted and select a handful to answer. We have set aside 10 minutes for Garry to respond to your questions. After Garry has finished answering questions, I will briefly mention the upcoming webinars and the 2010 International Symposium and end this session. I do want to note that this entire session is being recorded and will be made available on the ICSI website later for our members and for employees of companies. With the logistics out of the way, I now have the pleasure of introducing Garry Roedler. Garry has worked in systems engineering for Lockheed Martin Corporation for 25 years, in a career that has spanned most aspects of the full system life cycle and includes engineering leadership roles in both programs and systems engineering business functions. Prior to that, Garry taught mathematics at both secondary and college level. Garry is currently the Engineering Outreach Program Manager for Lockheed Martin Corporate Engineering. In this role, he's responsible for developing and executing an external outreach strategy for Lockheed Martin, involvement in industry associations to ensure effective collaboration and communication with those associations. Prior systems engineering roles include Senior Systems Engineering Program Manager for Lockheed Martin, in which he managed corporate councils for systems engineering, test and evaluation, and specialty engineering that focused on engineering practices, training, and improvement. As process manager for a business unit in Lockheed Martin, in which he was responsible for strategic planning of technology needs, process technology development and infusion, and process definition and improvement. This included achievement and sustainment of Level 5 CMM and CMMI objectives, including a world first to achieve Level 5 ratings in the SC CMM. He has had various technical leadership roles on programs and proposals, including technical lead and chief systems engineer for proposals, technical lead for systems installation, demonstration and deployment, customer liaison, and systems analysis manager. Garry holds degrees in mathematics education and mechanical engineering from Temple University. He is one of the first to receive the Expert Systems Engineering Professional certification from ICSI. Garry is the author of numerous publications and presentations. In addition to receiving the highest level awards within Lockheed Martin for technical excellence, Garry has received the ICSI Founders Award, various awards from IEEE and ISO, including being selected as a member of the IEEE Golden Core, and various awards from Practical Software and Systems Measurement. In addition to his responsibilities within Lockheed Martin, he has maintained leadership roles in various technical and standards organizations, including U.S. Head of Delegation and Task Group Leader for ISO, IEC, JTC1, and SC7 Working Group 7, ICSI Corporate Advisory Board Co-Chair and Committees, ICSI Delaware Valley Chapter Co-Founder, PSM Steering Group, and IEEE Standards Association. Garry has worked on the author teams of several current standards, including Project Editor of ISO IEC 15288, Systems Lifecycle Processes. Garry, the virtual floor is yours.
Okay, thank you very much, Andy. Can you hear me okay?
Yes.
Okay. And I apologize for the sounds in the background as people are beeping in. We will next time try and make sure that the phone line doesn't allow for that. Today I will be talking about a project and the resulting guide for systems engineering leading indicators. Please note that this webinar is not intended to be a tutorial on leading indicators. It will present the background of the project and an overview of the guidance developed by the project. There's been a growing interest in the past several years in the effectiveness of systems engineering from ICSI, DoD, and others. Several of these activities were catalysts there were several activities that were catalysts of this interest, including DoD's SE revitalization activities and various industry studies on the value of systems engineering. One of the DoD activities was the Air Force workshop on systems robustness, which asked relevant questions of systems engineering effectiveness, including, how do you know if a program is doing good systems engineering? As a result of the Air Force workshop, an action team was formed to study and establish guidance and definitions of systems engineering leading indicators. The team was formed as an industry-wide collaboration of MIT's Lean Aerospace Initiative, which is now the Lean Advancement Initiative, the International Council on Systems Engineering, or ICSI, Practical Software and Systems Measurement, or PSM, and several industry corporations. Donna Rhodes of MIT and I were the team leaders. As a framework, the team adopted the measurement process and information model of ISO IEC 15939, which is the measurement process, and of PSM. This chart shows the collaborative team as it has grown for the recent revision. As you can see, the team included many notable industry, academia, and government organizations. It's a very robust team with a number of very good experts. The Systems Engineering Leading Indicators project had several objectives as listed here. An essential part of defining any measure is the identification of the information need of the stakeholder. That is, what information does the decision maker need to make an informed decision, in this case, regarding effective systems engineering application. So one of the objectives was focused on understanding and defining those information needs. The project also needed to identify, define, and document applicable, high-priority, validated leading indicators to address the information needs. Since the project is focused on system engineering leading indicators, it was important to define this key term. A systems engineering leading indicator is a measure for evaluating the effectiveness of how a specific systems engineering activity is applied and provides insight into likely impacts on system performance objectives. The indicators can provide insight into future system performance or impacts to the system engineering performance. The key is that the indicators provide predictive information before the performance is adversely affected, thus allowing decision makers to determine proactive action. Traditionally, projects have focused mostly on financial indicators. Although necessary, these do not provide insight into the engineering performance and are usually dependent on the performance of engineering. So these are lagging indicators that identify when fires have already started. We want insight much earlier than the point of seeing the fire. Engineering status measures such as red, yellow, and green provide some insight into engineering performance, and if monitored across time periods, can give some understanding of trends in engineering performance. These are more like fire alarms of engineering performance. Using engineering performance measures that clearly show past performance along with trends and projections provide better insight into likely future performance if no change actions are taken. These are like smoke detectors and can allow action to be taken proactively where there is a blaze. Finally, the optimum is to have the data that fully allows understanding the engineering capability as well as its relationship to other factors and indicators and their contribution to performance and variances. This is like having a full understanding of the existing sources of ignition that could eventually start the fire. For this project, our objective was to at least define systems engineering leading indicators that fall into the engineering performance category and strive to get the data that would allow us to do the analysis to go further. This is the measurement analysis model from PSM. It will help to demonstrate some of the concepts we're looking at in terms of relationships to provide additional leading indications. It shows some of the key relationships between categories of measures. Ultimately, we would like to fully understand the relationships between the indicators in order to better understand likely downstream impacts so we can take the best set of actions. So, for example, if requirements grow in number, the product size usually increases, resulting in more effort. The additional effort leads to schedule delays. If the schedule is not changed accordingly, then the schedule pressure that results can cause more defects or result in insufficient testing. This, in turn, impacts the product quality. Any of these can impact the customer satisfaction. So what we're trying to do is understand the relationships and to be able to then understand how these interact, and it would be best if you can do that in a quantitative manner, but at least even if it's qualitative, to understand the interactions of what to look for downstream when you see something happening. The more we can understand the relationships, the better we can make proactive decisions that improve the engineering performance. We realized that there would be numerous candidate indicators that could be considered. So we established the criteria here to help prioritize the candidates for inclusion in the guide. Each selected indicator needed to be able to be introduced early in the activity flow, allow for data collection while the activity was being performed, and provide regular feedback, especially in support of reviews. It is hard to collect reliable data after the fact, so it needs to be part of the process. It is also most useful to be able to get the necessary insight early and often. In addition, the indicators needed to be objective, based on data, not subjective assessments, and tied back to information such as goals or obstacles. The bottom line is that decision makers need to have confidence in what the indicators are telling them. So we use this as a means of trying to prioritize the candidates. The result of the project was a Systems Engineering Leading Indicators Guide. And that guide, the original guide, had 13 leading indicators defined by a team of systems engineering measurement experts. A beta version was first released in December of 2005. We chose to release a beta version in order to validate the indicators. A series of validation approaches were used, including pilot programs, workshops, and a survey of program and engineering decision makers. This survey had 106 responses and focused on the utility of the indicators for providing insight. The survey confirmed that the 13 indicators had reasonable utility, and we'll look at the results on that on a later chart. Following the validation, version 1 was released in June of 2007. So we basically gave about 18 months of a validation period in order to make sure that what was in the guide had utility and would be useful for programs. While version 1 was in use, the team gathered user feedback for improvements and additional indicators for consideration. This resulted in version 2 being released in February of 2010. So this is the original set of system engineering leading indicators. There were actually about 23 candidate indicators identified. These 13 were the final set after applying the selection criteria we discussed. Each of these addresses important information needs of decision makers. Obviously, this set doesn't cover every information need for any program, but we needed to start somewhere and work based on priorities and resources available. While the titles of the indicators focus on trends, the detailed information on many of them also look at relationships between the indicators. The indicator descriptions are written to be very tailorable and include a range of application information, and we'll talk about that on another chart. In version 2, we added these indicators after doing some gap analysis and prioritization. So the current version now has 18 indicators defined that span a fairly broad part of the systems engineering arena. For each indicator, the detailed description includes this information, starting with the information need that it addresses. The measurable concept is the specific question or questions that the indicator answers with respect to that information need. The descriptions include a description of the leading information provided. That is, what future insight does it show? What's really leading about this indicator? Sometimes that comes down to how it is applied as well. Additionally, the description defines the base measures, which is the data needed, the derived measures or mathematical functions performed on the data, the indicator description, which includes what the possible indicator formats are, the thresholds, decision criteria, and interpretation information. Finally, there is some additional information to aid understanding and usage of the indicators, such as assumptions applied and implementation considerations. So this all forms what we call the indicator specification and is intended to provide the level of information which would allow the program team to tailor for the specific needs on their program and be able to then implement them for analysis and usage. So now let's look at the outline of the guide. It can be obtained at the links shown as well as also from the MIT website. It has a short description of the document, as well as also an executive summary. But the bulk of the information is in Section 3, which contains all the indicator descriptions. In Section 4, it also has some useful implementation considerations, including a mapping of the application of the indicators to the processes and activities of ISO IEC 15288, which is the System Lifecycle Process Standard. This also is the basis framework in which the ICSI SC Handbook is structured. In addition, it has some references, and the appendices provide some useful extension information. For example, the NAVAIR Applied Leading Indicator Implementation Appendix is a method to determine mathematically valid correlations between the indicators based on your data. So we'll take a look at some of the specifics here. This chart and the next are only intended to show the format or layout of the indicator descriptions. Each indicator description has some textual information and sample indicator graphics. Note that each indicator may have variants provided that focus on a specific question or aspect of the indicator, in this case, requirements volatility and TBD/TBR discovery rate. Both variants are part of a larger focus of requirements trends. This chart shows the layout of the indicator specification information we discussed previously. It includes all the detailed information that will support tailoring the definition for specific application on a program. Since all indicators are not applicable across the entire life cycle, the guide includes a mapping of the indicators to the stages or phases of the life cycle. In this table, P1 through P5 represent the phases of the DoD life cycle, and S1 through S5 represent the life cycle stages in 15288, the System Lifecycle Process Standard. As part of the validation approach of the leading indicators, we conducted a survey of key decision makers on programs, including program managers, chief engineers, chief systems engineers or architects, leading systems engineers, and IPT leads. In the survey, the decision makers were asked to rate the usefulness of the indicator for determining the effectiveness of systems engineering on their program. The rating scale went from 1 to 5, with 5 being the highest utility, or critical. We expected that this would result in some indicators not being retained due to low scores, but the lowest score for the indicators was 3.9, so there was no strong driver to remove any of the indicators from the set. This chart shows the rating scale used on the previous chart, so we'll move on. Section 4 has 4 subsections that provide additional information on specific application of the indicators and the relationships between the indicators. One subsection looks at how to define a cost-effective set of base measures or the data to be collected that will support the greatest number of indicators. Since most programs are limited in how much of the budget can be applied to data collection, this will help get the most bang for the buck. This includes an affinity table of the indicators. It supports making trades between related indicators. Okay. In addition, there's a mapping of indicators to SE activities per ISO IEC 15288. This allows the team to determine which indicator or indicators are candidates for any SE activity. So this is very helpful in the selection process once you understand the information needs and the activities that are being performed to identify which may be the best ones to apply, or alternatives when you're trying to get a cost-effective set of measures. There's also information on the application of the SE leading indicators for human system integration and understanding complexity. During this project, NavAir worked as a part of the collaborative effort, primarily focusing on developing a method to systematically analyze the data for specific information to determine mathematically valid relationships. When a relationship is proven, we're calling those applied leading indicators. This is included as an appendix in the guide and provides an approach for validating the leading indicators, as well as identifying the most useful relationships between indicators, usually those with the highest correlations. Finally, we have been working with the SE Research Center that is funded by the U.S. government and is led by Stevens Institute of Technology and includes 14 or more universities. The CERC was funded to work a project on system engineering effectiveness measurement. The project looked at both quantitative and qualitative approaches to determine effectiveness. They put together a framework of 51 criteria for successful systems engineering and then performed an analysis of that criteria against existing measurement references. That analysis showed that the System Engineering Leading Indicator Guide addressed the greatest number of the criteria. Thus, the project selected the guide for the quantitative portion of their research and worked in collaboration with the team on the revision. The mapping for the 51 criteria is also included in the guide. So I guess we're ready to take some questions then.
Garry, thank you for a great presentation on leading indicators for system engineering effectiveness. Can you look over the questions that have been posed by the audience and select any that you'd like to answer in the time? I think we've only got a couple so far.
Yes, the question is there an electronic copy of the presentation available? And yes, there will be. It will be posted at the webinar site, I believe. Andy, maybe you can answer that specifically.
Yes, it will be in the ICSI discussion forum and in the webinar section of the ICSI discussion forum.
Okay.
Oh.
So that would also answer the next question, which was about the whether the slides would be available. Okay, the next question is, was the CERC study completely separate, or did your team collaborate? The study itself that looked at the 51 criteria against the various industry works was done independent of our team. After the analysis was performed, the CERC team went out to each one of the teams that had worked the resources or references out there and made sure that there was agreement to how they had been assessed against the indicators and discussion to come to a consensus on it. So in that sense, there was some interaction with each one of the teams to make sure that the analysis was accurate. So I hope that answers the question on that. The next one. Okay, so leading indicators are only good if there are trigger thresholds and actions to prevent future problems. This wasn't discussed. And that is, I agree that's absolutely the case. There needs to be thresholds. The thresholds need to be established based on your own organizational or program data. In each one of the indicator descriptions, there is a placeholder for thresholds and discusses on those where there may be some industry information that there may be something included. But in most cases, it will point to the need to obtain local information and establish thresholds that are applicable to that organization. And as with any measurement, you only get the return from the measurement if you take the right actions. In the case of leading indicators, we're trying to get future insight, predictive, that allows us to take actions. Those need to be taken, derived from the analysis in terms of when you exceed a trigger or a threshold, and or even approaching one based on trends that are being recognized. Okay, let me go down. Okay, this question that says, what are the SE leading indicators that are tied to 15288 assessment and control process? And off the top of my head, I don't have the full table in front of me, but you can download a copy of the guide from the links that were there, and you'll see in Section 4 the full table against the 15288 processes and activities. And you'll be able to get the information as to which ones correspond to that process. Okay, the next question is the guide meant to be used for military and defense type of product development as well as commercial product development? In fact, it was the majority of the participants in the collaboration, but not all, were from the military and defense sector. So yes, it is meant to be used for military and defense type of product development, but we also tried to keep in mind that it needed to be useful for other sectors as well. So even though it was being developed through primarily aerospace and defense, we tried to also put on a hat of other sectors. Okay, the next question is, what are the next steps after the February 2010 version 2 release? Are more pilots planned, or are these indicators in active use as case studies? That's a good question. The team does want to continue to collect feedback from usage across the industry, as well as to get more pilots and input from the usage. This will continue through the help of INCOSE, PSM, and MIT. So I expect that we'll see more of this as we go forward. I'm not sure who will be leading the team at that point, whether it will be myself or somebody else. But I expect that probably in a couple or few years we'll be ready to consider doing another revision. And in between, as we get information, it will be posted through INCOSE, PSM, and the Lean Advancement Initiative. Okay, next question was, has anyone attempted to apply these criteria to a real-life project? By criteria, I'm not sure whether this is referring to criteria for selecting measures or whether we're talking about the criteria for what makes a program successful. And in either case, yes, there has been work done in both cases to apply to real projects. The criteria for system engineering effectiveness that the CERC used in assessing the set of indicators here was applied to pilots that they were conducting. And we've also taken the set of a subset at a time of the indicators, and we have done some on pilot programs. So I think that covers that question. Okay, Andy, somebody would like to know the link to the INCOSE discussion site where the presentation will be posted.
Okay, if you go into the INCOSE homepage, www.incose.org, and you look, I think it's on the top left-hand side for member resources, you should see a link there to discussion forum.
Okay, there's next comment or question is, any comments on how easy it is to collect the data for the indicators? Now that depends on which indicators you choose. Most of the indicators were designed to collect data that is in common use across the programs. So whether it be number of requirements or things that would likely be available in process through the course of performing the system engineering activities. In fact, that's why that was one of the criteria, was that it could be collected early and in progress of the activity. So for the most part, I'd say in many cases, you're going to find that the data is the kind of data that would be easy to access. The more difficult thing to do is making sure you have the right mechanisms in place to capture that in progress and to be able to verify the data for its accuracy. So the more that you can do automated collection, of course, the less chance you have of having incorrect data or having bias in the data. Okay, the next question is says your measures of effectiveness scores were all close to each other. Did that give you concern about your scoring method, and did you look at a means of trying to distinguish more between their relative effectiveness? And yes, we did go back and talk to a number of the people who were surveyed, and to make sure that they understood the intent of the question and how those were being done. We weren't trying to necessarily rank order these, so it didn't really bother us that we were say this one's the best one and this is next or anything, because they actually are focusing on different information needs. Okay, so what we're really interested in is, do they have a reasonable level of utility in looking at some aspect of systems engineering effectiveness, or don't they? And so that's what triggered us then to at least go back and make sure that the question was fully understood that was being asked. Okay, the next question is, how did you come up with the additional 5 indicators, and how are you planning to maintain and modify the list of indicators? Okay, the additional 5 indicators, we used a number of things as input. First was feedback from users. The second thing were some exercises that we performed in a number or series of workshops. We conducted some workshops with the GEIA G47 committee, which is the Systems Engineering Committee that's now under Tech America. We had a couple workshops in the PSM users conferences, and MIT hosted a couple workshops. And in these, we were looking at what information needs have not been addressed the decision maker needs to have insight into, and what then, how would those translate into potential candidate indicators. The other piece that played into this was there was a survey that was done by Don Reefer through his network, including ICSI and some others, to look at where there were gaps in the set of leading indicators in the guide. That was done independently of our team and then provided to our team. So it gave us an independent look. So we brought all that information together, did some prioritization, and we actually had out of that prioritization about 8 or 9 candidates for the revision. And a couple of them fell off of the plate due to lack of resources or lack of available information, or they didn't meet the criteria as we finished defining them. For ongoing maintenance, that's that's still being figured out. We expect to still collect information through the various primary players of ICSI, PSM, and MIT. And as we get more information, we'll figure out when we need to do something either as an addendum or as a revision. Okay. The next question's a very good one. I'm not sure I have a good answer. It was there any consideration for how the effectiveness of these indicators scale with respect to program size, project size, specifically small projects, and in the context of effort required to collect these measures? I would have to say very generically that we tried not to define things in a way that would preclude any kind of project from being able to collect them. Now, a smaller project may not have the data collection resources there. They may not be using as advanced tools. So it depends. But that could also even apply to a larger project that was resource constrained. So that's, to the extent that we could think our way through it, we tried to make sure that we weren't turning this into only major DoD programs. Next question was, can you expand on TDR, TBD training as a measure of requirements development leading indicator? And for that, I would point you to the description that is actually in the guide. There's a section that discusses it and its interactions and the details. So I think that would be the best. If you have any questions specifically about it, feel free to contact me. Okay, it says, how tightly is the SE leading indicator criteria? How tightly coupled is the SE leading indicator criteria when leveraging SETR process developed by NAVAIR for project development? Not at all. There's not a tight coupling there. What we did when we were working with NAVAIR was mostly focusing on how do we improve relationships between indicators. So they worked with us independent of the SETR process. I'm sure this, they would have spoken up if it didn't work within that process. But okay, I think I have time for maybe one more.
We're getting some feedback on the line. If anyone else other than Garry and myself has their speaker not on mute, please can they put their phone on mute? Dial star.
Okay, this is a good question. Predictive metrics require a stable process to accurately project future performance. Do you feel that CMMI Level 5 certification is a prerequisite to leverage these system engineering leading indicators? And I say, I don't think they are. I think level 4 and 5 helps because in a level 4 or 5 organization, you generally are collecting data and analyzing it to establish organizational baselines that programs can use. I think the mentality of establishing thresholds and looking at things that way is there. It's built into the culture. I think it can still be useful even for a level 3 organization because there you're at least establishing common processes. It may not be stable to the level of what you're indicating here, but I think it still provides useful insight. Okay, so the level 3 organization obviously is going to have to at least be somewhat learn to grow into more maturity in how they address measurement. Okay, Andy, I wanted to leave enough time for you to give your closing remarks and talk about the symposium?
I think if you go for another couple of questions.
Okay. A couple of these would require too much time. Let's see here. Okay, it says, I found version 1 on the ICSI site. Are you certain version 2 is available? I've been told by the technical operations organization that version 2 was posted. If you're not seeing it on the ICSI site, you can go to the other link because I am absolutely certain that you can find it on the PSM website. So that was www.psmsc.com. But as of, I guess it was 2 weeks ago, I was told that it was posted on ICSI. So if I will check afterwards. If it's not available, we'll make sure it is.
I just downloaded it. It's available from the ICSI site.
Okay, thank you. Okay, can you speak on how SE leading indicators is now being incorporated into the SC Handbook as an SE process? as well as how it was developed from COSISMO, COSI RM, and COSI Technical Measures Guide. Yes. There's a new process that's been added in this version of the SE Handbook, version 3.2. The process is the measurement process. And the measurement process goes through the basics of measurement, but also has a section that gives a summary of SE leading indicators, of the application of SE leading indicators, and then points out to this guide. The relationship between this guide and the technical measurement guide is pretty much through the leading indicator on technical performance measures. So the technical performance measures will point out then to find more information to go to the technical measures guide. So there's a very strong relationship and alignment of these documents. The last part of this was with COSISMO, and we had some of the same people working on this team as on the COSISMO team, so we tried to maintain consistency and alignment between all these references and assets. Okay, this may have been answered in the guide, but how would you recommend collect the data? I think it has to be that these indicators are part of the program measurement planning. And so the systems engineering leadership needs to work with whoever is responsible for measurement on the program. Often there's a measurement analyst who's assigned. So the systems engineering team needs to work with the measurement analyst and make sure that the data collection is planned for. We've identified where in the process it can be captured, especially automated if it can, and where to store the data, kind of normalization or preparation of the data that's necessary for analysis. So all that should be part of the planning. Okay, Andy, I'm going to turn it over to you.
Okay, thank you again, Garry, for a great talk, and thank you to the audience for your questions and your time.
Some great questions.